Here we are, actually finishing up week 3 for Intro to Networks and OS2. So this is OS2. We did a little more work on theory. We're just a little behind. Just a little bit at CLI, and students had a little bit of time to finish up their GUI assignment. We moved the devices over to the DMZ. And we tested them, so I think we should be good there. Alright, so let's get going. From the class before, we had some of the diagrams. So we have a shell, like the bash shell allows us to type commands, or a CLI in a router or a switch type commands that communicate with the kernel, and the kernel communicates with the hardware. Now, we're working with switches in the other class. Okay. I'm working with switches in the other class. And we talked about RAM, running config in the RAM, boot from the read-only memory, startup config stored in NVRAM, and the iOS and the flash. But all hardware has basic things. They have some type of memory, a processor, maybe some way to storage, maybe all that's flash. They have some way to boot, some software to boot. They have a way to communicate in and out. Right? One way or another. So the kernel will manage resource access and process scheduling. Resources, resources are the processor, the RAM, the storage, any I/O, accessing ROM, all that hardware that move the information through the bus, and then of course we got to have some logical way to schedule those things. So that would be a definition of the kernel, and then we talked about the processor, or internally in the computer you're either working in kernel mode, in which it's doing these things, or user mode, in which a user piece of software is actually functioning. Okay, and then we just compared that to this idea of switching between these two. You can switch between them. You can switch because of a software interrupt, a hardware interrupt, or some exception occurs. That make sense? Okay, the software interrupts whatever process because the software needs to access some way down here, maybe the hard drive. Hardware, you could be, let's just look at a crazy example, maybe you're loading in a huge file, and then when the file's done, the hardware can interrupt and tell the kernel, hey, we're done doing that. We gave the example of an exception. There are going to be a lot of different things for exception, but we gave the example if the software, your operating system's functioning, and then something unusual happens, maybe an interruption, and then it needs to do something else. We gave the example of like a self-driving car or something like that, or a car that's got assist, and so the computers are running the car, it's going down the road. I gave the example, all of a sudden an airplane crashed right in front of you, and you hit the airplane. Okay, the car, no matter what, didn't have time to stop, and what kind of interrupt would there be? The systems would have to interrupt and deploy the airbag. The computer system would have to deploy the airbag. And it'd have to do that very quickly. So it would be an exception. You don't expect that to happen, but you do. You have to change control over to somewhere else in order to do something. Crazy example, but it's the best I can come up with today. Okay, let's move on. Next thing we talked about is a process. Okay, is a program plus its execution context. Programs, if we were, I don't think I wrote it up here, but if we were to define a program. A program would be this compiled file that's maybe stored out here on a hard drive. Okay? You know, the instructions and so forth. Maybe on a hard drive, maybe somewhere in flash, and then when we bring it into memory, and we're going to start executing it, it becomes a process. I'm not going to go through all the details, but what we create is this location in memory. These are the program instructions. There's the data that goes with those. We got this, and we got the heap, and then we have some space, and then we have the stack that's keeping track of the context. It's keeping track of which instruction, you know, like down here, which instruction was the last one used, where we need to continue, and why would we need to do that? Well, there may be an interrupt, and this program stops, and another program starts executing. So it'll have its stack of everything it needs in there. Okay? So the process is either ready to be executed, it can be running, or it may be blocked, like if there was some I.O. And then some I.O. Either it was ready and then there's some I.O., so it's blocked, it's not going to be executed yet, and then it can be brought back to ready. But a lot of times it's ready and running, okay, and then maybe it's ready. And what keeps track of this stack or whatever? Well, interrupts can move between the two, or just plain scheduling. Okay? Now, let's move. Yeah, here's the last thing. We took their Linux machines, and there's a network here. The DMZ. And we connected computers. Actually, there was another switch too. Oh, that's not a very good place to draw it. And there was another switch, but we connected in to the DMZ with our workstations. Why to do that? Well, if you're running SSH on your machine, you can remotely come in and log into the work server, and then from the work server you can log into your machine. Or, like for networking, you can log into this device, which then gets us to networking devices. This is the default gateway, and we decided to use some addressing, so we went 172.21, 20, 101, up to like whatever we ended up with, 118 or something. Mask /16. So they gave them all static addresses. And when the students left, they said it was working, so if I get time, I'm going to check it tomorrow afternoon. Well, that's it for today. A couple key things. Let's just jump up to a blank page here. The curriculum, let me undo that. The curriculum, so now you got three things. You have to go through the materials. You got to do the labs. Yep, these are labs 0, 4 on. And then you have to do the exams. Whoa, let me see if I can write that a little better. And you need to keep track then of the due dates. so you don't fall behind. And then we finished up, or you should have finished up, the GUI work, and now we're going to be doing a lot of command line interface work over the next week. And you should be able to, from home, log into your machine here on campus if you need to, and you want to use that because you have full access to that. Alright, that's all I have for this week. Let me know if you have questions.